Welcome to the video lecture of material science. Today we will going to discuss about different types of annealing process. So basically there are 7 types of annealing process. Depending upon upper, below and above critical temperature, this differentiation has been done. The processes are complete annealing, diffusion annealing, incomplete annealing, spherification annealing, isothermal annealing. These 5 types of annealing process has been done above critical temperature. And next to recrystallization annealing and stress annealing has been done below critical temperature. So let us remind what is annealing process first. The process of heating a metal or alloy to an appropriate temperature for a certain period of time and then slowly cooled, generally with the furnace cooling, is called annealing. The essence of annealing is the transformation of the perlite after heating the steel to austenizing. After annealing, the tissues is close to that after equilibrium. What are the purpose of annealing? To reduce hardness of steel, improve plasticity, and facilitate machining and cold deformation processing. Second, the chemical composition and organization of uniform steel, refining grain to improve performance of steel or to prepare for quenching. Third, eliminate internal stress and process hardening to prevent deformation and cracking. Annealing and normalizing are mainly used for preparing heat treatment. For parts with low stress and low performance, annealing and normalizing can also be used as final heat treatment. Now let us come to the classifications. The 7 types of annealing process. In the first one, complete annealing. The process is heat the steel above AC3 line. Actually this is AC3 line. In iron carbon transformation, phase transformation line, this is actually AC3 or A3 line. So heat the steel above A3 line 20 to 30 degrees centigrade. Heat preservation for a period of time after slow cooling along with the furnace to get closer to the balance of heat treatment process. Completely austenizing. The total annealing is mainly used for subeutectic steel 0.2 to 6%, generally medium carbon steel, low medium carbon steel, low medium carbon alloy steel, castings, forgings and hot roll profiles, and sometimes used in welds. Low carbon steel has low hardness. As we know, if we increase carbon content in steel, that will increase hardness. Carbon is the brittle material, and it will, if we increase in substance, it will increase the hardness property of the material. Now when hypereutectic steel heated to above ACM austenite state and slow cooling annealing, precipitate in mesh along the grain boundary, the strength, hardness plasticity and toughness of steel, and significantly reduced with leave a hidden danger to the final treatment. Objectives are to find grain, uniform structure, eliminate internal stresses, reduce hardness, and improve machining of steel. As we know, if we improve ductility in material, it will increase the machinability of that material. In order to improve productivity in the actual production, the parts will take out from the furnace for air cooling when annealing cooling to about 500 degrees centigrade. Next is isothermal annealing. Complete annealing takes a long time, especially when the austenitic steel is more stable. If the austenizing steel is cooled to a slightly lower than A1 line, this is our A1 line, it's a temperature, and then it will be cooled to room temperature, which can shorten the annealing time greatly. This kind of annealing method is called isothermal annealing. Process is heat the steel to a temperature higher than ACT line. Above this line we have to heat the material, heat the steel, that means above upper critical temperature, then cool it down below lower critical temperature. It can be cooled to a certain temperature in the perlite area. This is our perlite area. And then austenitic body will be changed into perlite. And then the heat treatment process will be cooled at room temperature. Objectives are same as complete annealing, suitable for steel with more stable high carbon steel which have carbon content greater than 0.6%, alloy tool steel, high alloy steel which have carbon content greater than 0.1%. Isothermal annealing is also beneficial to achieve uniform organization and performance. However, it is not suitable for large section steel parts and large batch furnace materials because isothermal annealing is not easy to achieve the isothermal temperature of the internal or batch workpiece. Next is incomplete annealing. The process of incomplete annealing is heating the steel to A1 to A3 line, hypoeutector steel, A1 to A2 line is this, some temperature, A1 to A3 line is this. So the heat treatment process is obtained by slow cooling after thermal insulation. It is mainly used to obtain spherical perlite tissues for the hypereutector steel to eliminate internal stress, reduce the hardness, and improve the machinability. Spherification annealing is a kind of incomplete annealing. Next, verification annealing. A heat treatment process for spherification of carbide in steel to obtain granular perlite. Process is heated to the temperature which is 20 to 30 degree higher than A1 line. Above A1 line, above 723 degrees centigrade, we need to heat the material, the steel. Holding the time should not be too long, generally 2 to 4 hours, usually by furnace cooling method or isothermal in about 20 degrees centigrade below A1 for a long time. That means we have to increase the temperature above this A1 line, above cement density 20 to 30 degree, then cool it down below A1 line 20 to 20 degree and keep it for long time. After heating it, keep it for 2 to 4 hours, then cool it down to below 723 degree, 20 degree below 723 degree, that means near about 700, and keep it for long time. It is mainly used for eutectoid steel and hyper eutectoid steel. Eutectoid steel means which have 0.83% carbon content. Hyper means 0.80 to 2%, 2.06%, and hypo means 0 to 0.83%. Such as carbon tool steel, alloy steel, bearing steel, it also used. After rolling and forging of hyper-eutectoid steel and air-cooled tissue is perlite and reticular cementite. This kind of tissues is hard and brittle and not only difficult to cut but also easy to deform and crack later quenching process. Spheroidizing annealing gets globular perlite. In the globular perlite, carbonized body appears as a spherical particle and the dispersion is distributed on the ferrite matrix. Spherical perlite is not only low in hardness but also convenient for machining. In addition, the austenite grain is not easy to be coarse when it is heated and the deformation and cracking tendency is small. If there is reticular cementite in the eutectic steel, it is necessary to eliminate the normalizing process before the spheroidizing annealing so as to ensure that the spheroification annealing is normal. Objective of this spheroification annealing is to reduce hardness, uniform structure, improve machinability, to prepare for quenching. There are many methods for spherification annealing, like after steel heat insulation along with the furnace cooled to slightly below A1 line, and keep below A1 line 10 to 30 degree. After isothermal with the slow cooling furnace to about 500 degrees centigrade, then take out for air cooling. It has an advantage of a short period uniform spheroidization and easy quality control. Reciprocating spherification annealing process is also another type of spherification annealing process. Next is diffusion annealing, or you can say uniform annealing. Process is heat the casting or forging billets to a temperature that is slightly lower than solid phase line for a long time, then slowly cool down to eliminate the unevenness of chemical composition. Objectives are to eliminate the dendritic segregation and regional segregation in the solidification process, to homogenize the composition of the organization. The diffusion annealing temperature is very high, usually for 100 to 200 degree above A3 line, 100 to 200 degree above A3 line, or above ACM line. This is our ACM line, this is A3 line. The heat preservation time is usually 10 to 15 hours. After diffusion annealing, complete annealing and normalizing are needed to refine the tissue. It is applied to some high quality alloy steel and segregation of serious alloy steels, casting and ingots. Next is stress relief annealing. The process is heat the steel to a certain temperature below A1 line, so the 500 to 650 degrees centigrade insulation, and then cooling to the furnace. The stress annealing temperature is lower than this A1 line temperature. The stress annealing does not cause organizational changes. Objectives are it's reduce, it's eliminate internal stresses. Our next is recrystallization annealing. Recrystallization annealing is also known as intermediate annealing. It is heat the whole deformation of the metal to a recrystallization temperature to maintain the appropriate time so that the deformation gain can be changed into uniform and equal axial grains to eliminate the process hardening and residual stress. The generation of decrystallization must first have certain amount of cold plastic deformation, and then it must be heated to above certain temperature. The minimum temperature for the recrystallization is called the lowest recrystallization temperature. The lowest recrystallization temperature of general material is 0.4, that means 40% of molten temperature of the steel. Heating the recrystallizing annealing temperature should be higher than lowest recrystallizing temperature of 100 to 200 degrees centigrade. The minimum steel recrystallizing temperature is about 450 degrees centigrade. Slow cooling after proper heat preservation is required. How to choose annealing method. First of all, the various steel of hypoeutectoid structure generally select complete annealing. In order to shorten the annealing time, isothermal annealing can be used. The spheroidizing annealing is generally used for hypereutectic steel when the request is not high. You can choose not to complete annealing. Tool steel, bearing steel is often used to spheroidizing annealing. Cold extrusion, cold upsetting parts of low carbon steel or medium carbon steel are sometimes used to spherified annealing. In order to eliminate the process hardening, recrystallization annealing can be used. In order to eliminate the internal stress caused by various processes, stress annealing can be used. In order to improve the inhomogeneity of the structure, chemical composition of high quality alloy steel, diffusion annealing often used. This much for today. We will discuss more about different type of heat treatment process in next class. Thank you.